All right, so continuing through our 30,000 foot view series here, let's remind ourselves where we just finished up. So we were talking about what to do with pyruvate and the fates of pyruvate. And so we had finished glycolysis. We have pyruvate. We take pyruvate through pyruvate dehydrogenase chemistry to generate acetyl-CoA. And again, the purpose of doing that, let's remind ourselves, the purpose of sort of doing that pyruvate dehydrogenase chemistry is we have to do something with pyruvate. So again, taking pyruvate on and converting it to acetyl-CoA pulls pyruvate out of that glycolysis pathway, and so glycolysis can continue. But importantly, it also regenerates NAD+, because if you remember, NAD+ is necessary for glycolysis. So if you don't regenerate NAD+, you cannot continue glycolysis. So this is what happens under aerobic conditions, and we sort of talked about the fates of pyruvate being different, whether you are under aerobic conditions and sort of you continue on through pyruvate dehydrogenase chemistry, or we talked about under anaerobic conditions, you enable fermentative pathways. And in this case, in humans and mammals, it'll be homolactic fermentation. You convert pyruvate into lactate, again, serving that dual purpose of doing something with pyruvate, removing it sort of from the system, and also regenerating NAD+. Lactate dehydrogenase does both of those at the same time. Okay, but highlighting lactate is sort of this dead-end metabolite. We need to reverse sort of this process and pay that oxygen debt to sort of get further through our metabolic chemistry. So what we're going to move on to now is discuss another anaerobic chemistry, another fermentative process. So anytime we're talking about doing anything under anaerobic conditions, we're probably going to need to involve a fermentation pathway. And in this case, we're going to be talking about alcoholic fermentation. And the enzyme responsible for that is alcohol dehydrogenase. So again, this is alcohol dehydrogenase. Now, we've talked about this enzyme before. We actually talked about this enzyme when we talked about why methanol poisoning is so toxic. And that's because alcohol dehydrogenase in mammals and humans will use methanol as a substrate. Now, remember, alcohol dehydrogenase chemistry for us operates in this directions. So for humans and other mammals, right, it operates to convert ethanol, okay, into, in this case, it doesn't go back to pyruvate per se, but it converts it into acetaldehyde. And so that chemistry is toxic when methanol is there because then you generate formaldehyde. Okay, so again, humans only operate in this direction, but as we think about sort of fermentation chemistries, whether it's beer production, wine making, kombucha, things like that, where we do anaerobic fermentation, this is how they satisfy those two stipulations that we need to make sure happen. We need to do something with pyruvate, so do something with pyruvate, and we need to regenerate NAD+. So just like lactate dehydrogenase did double duty, alcohol dehydrogenase in organisms that allow it to work in this direction will also do double duty. So again, doing something with pyruvate. So pyruvate is going to be a substrate here, so we are removing it from the endpoint of glycolysis, and then regenerating NAD+. Okay, so again, looking at sort of the substrates that we have, we've got pyruvate here, that there's actually two things that happen. We ultimately snip off one of those carbons as carbon dioxide, and then we generate acetaldehyde, which is then reduced to ethanol. So the last piece that I want to sort of highlight here is talk about why fermentation chemistry is so important from sort of a beer and wine making sort of process, is if we look at the other two products that are here, and I'm going to highlight here, when organisms like yeast or bacteria who are undergoing anaerobic alcoholic fermentation do this process, this is why they're doing it. They want to get rid of pyruvate and they want to regenerate NAD+. They don't necessarily care about these two products. Truthfully, alcohol or ethanol is toxic. And so again, this is a problem because this is a toxic byproduct. Okay, and then the CO2 just sort of gets eliminated. But here's why this biochemistry is important to the beer and winemaking industry, is this piece is how you make an alcoholic beverage. I can't spell beverage. And this is how you carbonate it. So this is how you generate a carbonated beverage. And these, even though they are the unintended, unnecessary, undesirable side products from alcohol dehydrogenase by yeast and other organisms, these are the two pieces that are sort of the hallmarks of why brewers will undergo alcoholic fermentation chemistry, is to generate an alcoholic beverage and then carbonate it. And we'll review all of that chemistry when we do our own beer making in lab.